Good morning, everyone. We're going to be starting the webinar in just a couple of minutes, waiting for a few last-minute people to jump in on the session. We're going to start the session in just a minute. We're waiting for a couple more stragglers to jump in. Good morning. I'd like to welcome you to HiQA's latest webinar, Real-Time Shop Floor Data Collection Improves Your Quality Manufacturing Process. Just want to go over a couple of housekeeping items before we begin. The webinar presentations are scheduled to last approximately 45 minutes. There'll be a 15-minute Q&A session following as time permits. Please ask your questions at any time during the session by clicking the Q&A button at the bottom of your screen. We'll answer as many as we can. Any question that we're unable to answer because of the time frame will be responded to by email after the fact. Our presenters today include Sam Golan, founder and CEO of HiQA, and Chris Medicino, our Vice President of Product. And at this point, I'd like to turn the presentation over to Sam. Just remind Sam that you need to unmute your microphone once I turn it over to you. And here you go.
Okay. Share my screen. And I believe that you can see my screen all. And I will ask my colleague if I'm getting unmuted. I may have some issues sometimes with my audio, which is supposed to be good. Just let me know.
Sam, we can hear you and we can see your screen.
Perfect. So thank you all for taking the time participating today to our webinar about real-time shop floor data collection. And as you see, I kind of highlighted the real-time. And what does it mean, real-time shop floor data collection? Don't we collect data in real time? When we inspect data on CMM or VMM, don't we collect it real time? Or when we inspect, in process, it is not real time? Well, I will leave open this topic and we'll get back into it in the next couple of slides. When we are talking about quality or Industry 4.0, I believe that we all know or heard about this revolution of Industry 4.0, where Quality 4.0 is a subset. Quality 4.0, it's about data. And it's not about just a data, it's about a lot of data. It is about a lot of data from multiple resources. But getting data from multiple resources are not helpful at all if you don't integrate between those data resources. It is not helpful if you don't analyze the integrated data real time that will provide you a valuable information. So the key is not about the data, but about useful information that you can take decision when you need it, and not as a post-mortem when it's too late and actually too expensive. Understanding when we talk about the gap quality industry needs to close to comply to quality 4.0 when we talk about data and being able to utilize real-time information. This is a kind of illustrated example. How many data sources we are using to complete quality process from 2D print or 3D model, if you will, to get to the report or a package submission. Where and how all each data source stored, how useful this large amount of data when you need it as an analyzed information, which is useful for you to take a decision in this minute that you need it. This data should be automatically available based on your current process now, not when the part is out already, which is too late. In more advanced organization, there are what we know a kind of like integration project using platform like SharePoint or ERP. But these solutions are more of a metadata repository. It's not about the content. It's about the metadata. It's about the part. It's about the report, but not the real content. And that's not useful when you need it. Another example, you probably know how many inspection tools are out there. Hundreds tool types and thousands of inspection tools. And again, when we collect data in certain step, when we collect data in certain location on the shop floor, on the part in certain steps, where all this data goes. Sometimes, you know, people writing in on piece of paper and someone enter it to an Excel. There are somebody clicking to the ERP system. And what is the value that we are getting on this data? There are so many cases that this data is there, but actually we don't have any value except what we call after the fact, the post-mortem. It's too late and too expensive. If we look to another source of data, SPC, for instance, this is also very good tool to kind of try to expect what's going to happen, the trends of a part, consistency, stability. But actually, what happened is we upload data after we inspect the part, and then there is a great chart and X bars and histograms. But can we get it real times? Can we get something now that we can fix the process? So again, data, it's great, but if it's not an information, then it's a challenge. Another maybe last example that I would like to talk to you here is the APQP. And APQP kind of like 99.9% of the industry are using Excel for APQP. For the people that are not really familiar with APQP that comes from the automotive industry is advanced process quality planning. And this is the kind of the Bible of this industry, and it started to be adopted by medical recently and aerospace also in the future. But APQP present or represent tons of data on multiply Excel tabs with no real value except of satisfying customers' requirement associated with massive labor intensive. People are spending days to fill up APQP. And what is the value? Question is very, the question mark is very big. As one of our very large customers said, when I visited him, he said, well, I have a lot of data. I don't know why it's not popping up. I have a lot of data, but actually I do not have any information when I need it. I have 75 people on the shop floor collecting data every minute, and it goes all over the place, and then it's stored in boxes or in folders, but I get it when I having auditors coming in or customer comes to complain. So what we would like to do, we would like to present today a different way, how it's real time become real time, and what you can do with this data when you need it. Kind of quickly about HighQA. We are a quality management system. We enable companies at any size, small to enterprise, to automate their processes with manufacturing quality, either internally and with supply chain. This is our nice office in the summertime. We don't need to spend time here, but I think it's important to look into some of our customer list, and it's actually represent a variety of a range from small, mid, large enterprise OEM companies, as you see here, BAE, Lockheed Martin, Rolls-Royce, and there are smaller and even many job shop. And here is when we talk about real-time shop floor data collection, why real-time is associated with comprehensive or all-in-one system. When you collect data on the shop floor, there is a resource for the requirement for the data they collected. So when we talk all-in-one system, it starts from 2D or 3D part, and you have all the components in place, not as a separate application or separate package that then you need to go and connect between them to get the data that you need. So all of this, when we talk about this side, which is downstream preparation, when you take 2D or 3D and create the process, either for internal manufacturing or even external supply chain. Then comes the automated data collection that can be used by CMM, VMM, manual, Bluetooth, wireless, whatever tool, and then come the reporting. And that's all in one. But what enables us to have all-in-one system is because this infrastructure that heats centralized database. When you have database-driven application, encapsulate all those functionality and capability in one cohesive database, this is the base of when we talk about real-time of information and not just data. Then there is a layer of integration with other systems if required, like ERP and others. And then there is user access control. There are many layers of capabilities. Then we deal with the data source, which is 2D drawing or 3D model. Then comes the APQP layer, which is a module. If you need it, fine. If you don't, you don't. But it's not Excel anymore. It's integrated. It's an application. Then comes the very robust layer of functionality that enables you to take a project from A to Z. You have assigned it to the shop floor or external, like supply chain, and then comes the data collection. And data collection is connected directly to the source of the data. It's not a metadata, it's a data. And it starts with 2D, with automated ballooning GD&T that extract, which eliminate interpretation. It can start from a 3D that enables you to do it. And then, of course, come the shop floor data collection that you can see here in this slide, that we support all data source from the shop floor, data that comes from a machine that generates digital results like CMM, VMM, or wireless Bluetooth tools, and manual inspection tool like gauges and manual micrometer, caliber. And then comes the data collection module that run on PC or a tablet, as you see here. And when we talk about real-time data collection, when we talk about SPC that gives you real-time, this is a simulated, a screenshot that probably Chris will show us later. When someone on the shop floor collect data and there is the control limit, it's real time. You can see exactly what happened when he collects data. And if there is something that going to take it to a risk level, going close to the control limit, the system will alert him and other relevant people because all of them are on the same system. So kind of in a nutshell, from the challenges of real-time shop floor data collection, because it's not stand by itself. We don't collect data just to have it as a data. We have to have a data that provides us information when we need it. So at this point, I would like to transfer the presentation rights to Chris. And again, thank you for taking the time today to join. Chris?
Yep, thank you, Sam. Just sharing my screen here. You guys should have that now.
Yep, Chris, we have your screen and your voice.
All right, great, thank you, Jack. All right, excellent. So yeah, as Sam was saying, the discrepancy between data and information cannot be really understated. So the two sides to our system that we have that we talk about here is the ability to set up a detailed plan and a detailed set of requirements, right, for your inspections that need to be performed on your parts. Okay, and that starts with the balloon drawing here. All right. And then the ability to collect data from a variety of sources against that plan. Okay, so what we're going to walk through today is a few things. So we're starting with an inspection plan, a list of criteria that need to be inspected for this part. All right, this part has multiple operations at which various or particular dimensions are inspected at each operation. Okay. And so we even have the way this gets set up is very simply, this one's already prepped, but we've created unique inspection plans effectively at each of these operational stages. Okay, so we'll talk about why that's important in a minute. But what I want to first focus on, let's think about this just from a very simple standpoint of an FAI, right? And so if we think about this just from the FAI piece, let's say we do our inspection on a CMM and we want to import the results data from a CMM. Okay, so I can import the results by going up here, saying import from file, and I have a sample CMM data file here that presumably has some results in it. So we'll bring that in, and we're going to import that just like so here. And you can see the results that come in against that. So there's a couple of different ways that we can engage with CMMs, but ideally you're setting it up with some automation. And so we can automatically import all of the CMM results data that's coming out of however many CMMs or VMMs or any automated inspection equipment. We'll just generalize by saying CMMs. But we can import from virtually any CMM, VMM on the planet that'll output some sort of results data file. And we can do that through some sophisticated automation means. Okay, and so what you're seeing here now is I have a particular part here that, and all of the results on it. So if it's green, that means it's passing. I can get immediate feedback on whether it's the results are passing, or red here, this one failed. So when I click that, the whole UI is kind of synchronized here. So I can dig into my results here and figure out, okay, what went wrong? This one, it's a ++ tolerance here. So I can see my out of tol was 1,000th, right? And I can see who measured it. I could see what the gauge was. If that data was being collected, I can see what the gauge was that reported this particular result, okay? And we'll talk about gauges in just a minute here as we get a little further in, because when we're talking about data, it's not just the result data itself, but it's also the timestamp of when the result was collected. It's who generated the result, who was the CMM operator, or who was the inspector doing a manual inspection. And then where were they, like what was the inspection location that they were at, what operation were they working on. There's a whole variety of items that we would want to know about our samples and about our inspection. Okay, so that would be just being able to import data from a CMM. I'm going to clear this and we're going to take a step back for just a minute to look at this in a little more detail. So beyond just part records, we're also managing jobs, lots, and samples themselves. Okay, so this is not just an FAI software like many other ballooning packages are. Many other ballooning packages stop at just that initial upload of results for a single piece. But we're actually managing production beyond that, right? So you can see here I have a job number for this part. I can have a whole series of jobs, right? And then within each job, I could potentially have multiple lots. Okay, so we can manage those and we can deal with things like you'll see here the AQL settings and such to be able to plan for the production inspection requirements. Okay. And then through that, what I did is I was able to create lot samples. Okay, so I already had this set up. So just for the sake of time, because there's a lot that we want to cover in this session. But you can see what happened here is that this lot has a quantity of 100 pieces. And per the AQL, I wanted to inspect a certain volume of pieces, okay, based on sampling rules and so on that were defined per operation, okay? And so I have an FAI piece here and I have a certain frequency of samples after that with varying inspection requirements, okay? So there's a certain quantity of samples that need to be inspected at each stage, okay, or for each piece, all right? So all of these currently are blank. They have not received any inspection results, okay? So what I want to do is take a look at the shop floor side and see how we would handle manual inspections, okay? Because once all this is set up, I can switch over and do my data collection on the shop floor. So I'm going to switch over to that. And you'll see here, this is our shop floor side. We have 3 different apps depending on the type of workflow you'd like to utilize. And something important to understand, this is actually driven through a browser. So I'm going to go out of full screen for a second. You can see I'm in a browser, just a standard browser to be able to work with this. So it's very light in that way, able to be deployed and managed easily by your IT teams. And where we'll start is using this particular workflow here that we have. So the flow is such that I would log in with my user. And the first thing I see is a list of jobs that I have access to as my user, okay? And so in this case, I just have one job that's queued up in the system that's active for me. And it's that job that we were just looking at. So I'm gonna select that. Now that job was queued up for 2 different inspection areas. There's a milling in process check, and there's 3 different operations within that, okay? And then there's a final QC area, okay? So depending on your user controls and permissions, I may only have access to this milling in process check, or I might only have access to the final QC. In this case, for the sake of the demo, I gave myself access to both, okay? And so what you'll see here is I'm going to go into the final QC area just to show you an example. Now, this gives me that same list of samples and it shows me each piece that needs to be inspected, okay, per this particular operation. Okay, so for final inspection, you'll notice the quantity of dimensions is much lower here than what we had in our original samples list. That's because it's only showing me what needs to be inspected in this operation and tracking the percentage completion per that operation. So this is all able to be managed really simply. It's very intuitive for the people on the shop floor to be able to quickly pull up what they need to be working on and what their requirements are, okay? And then when I click into these, so I'm gonna click into one of these right here because this one's just got 2 dimensions that need to be checked. So it's gonna be real simple to plug through that. So this shows me the exact dimensions that I need to check. This replaces the concept of a ballooned PDF and an Excel spreadsheet that most of the industry is used to working with, okay? That with something like this, the idea of using Excel and PDF and Adobe and all that kind of goes away. We don't need to manage independent files strewn all over a file share, a network anymore. We can have a much more sophisticated app that and a centralized database that manages all of our information much more intuitively. Okay, so this is walking me through a particular operation and showing me, okay, check this feature right here. Okay, this is a thread. You're going to use a thread plug gauge. It's a critical feature that you need to check. We're in kind of a production mode right now. That's the piece I selected. And so what I would do is I would select my gauge and I would select the result. Okay, so when I click on my gauge, you'll see what happens here. This is automatically filtering down for me because we have an entire gauge library, and I'll show you that in a minute here to give you some context for that. But we have a whole gauge library in our database. And so it's contextualizing that gauge library, though, based on the dimensions tool category that was recommended. So it's only showing me thread plug gauges, and it's only showing me thread plug gauges that are in the location that I'm currently at. So I'm at milling in process check. So it's hyper contextualizing the selection choices here so that I can easily say, okay, well, this is the thread gauge that I'm using. Okay, I'll select that. Now that's active, and I say whether it was pass or fail. They'll say pass, say accept, and it bumps me to the next dimension automatically. I'm still on a thread plug gauge for this thread, and so it's retaining the gauge that I had just selected, so I don't have to select it again. It assumes I'm going to keep using the same one as long as the category is the same. And then I can say pass again, accept. And here, I misclicked there. That's why that little menu popped up. I right-clicked on the screen. But here, now what it does is you measured both of the dimensions that needed to be checked at this op, right? And so it says, what do you want to do next? We can change the sample that we're on, change the procedure, change the lot. Where are we going to go? There's only so many options, right? So I'm going to say change and go to the next sample. So I say change, and it picks up in the list of the samples that need to be checked for this procedure. It says, hey, that's the one that you just did. And so this is the next one that you should go to that requires inspection in the list. So all I have to do is click next sample, and it's just going to bump me to the next logical one. Or I could select something out of sequence if I really needed to, but I click next and it bumps me to the next sample and I'm ready to go. Now, something important to understand, let me back up here because those are just pass fail attribute dimensions, but I'll go into this one that's got something that's a numeric input here. So we'll also deal with numeric input. So if we have something like this, where we can key in a value like so, now we're back to another thread like that. We can do that as well. And so something important to understand is here, let's go up to one of these. All right, so we can interface with digital gauges as well, not just keypad input like this. We can also deal with digital gauges. So if you have handheld gauges that are Bluetooth or kind of USB cable connected, some sort of digital input, then we can accept that push button signal from those gauges to automatically populate the result, and it's going to trigger the accept button automatically as well and bump you to the next dimensional input. Okay, so that can drastically streamline your inspection processes as well. And some of the gauges out there will actually transmit a signal as to the gauge ID that you're using. So when you click that button on like a digital micrometer or something, right, it will not only transmit the result, but it will also transmit the ID and populate both fields simultaneously. So you're doing less clicking and more inspecting. Okay, so that is all super cool. Now, to emphasize, centralized database, real-time data results from the shop floor, all this data that we just collected is already in that centralized database stored. I can see this back on Inspection Manager if I want to come back here, right? So if I just refresh my screen here, you'll see this was piece number 11 that we were working on. You'll see that my inspection requirements went down to 32 because I inspected 2 results there, okay? And then there was 1 result that we put in on this first piece So it's the total requirement is 101. I went down to 100, right? And so, and again, these counts are much higher here because this is looking across all operations versus on the shop floor side, we're just looking at one particular operation. Okay. So another thing comes up though, what happens if I input a failed result? Okay, so let's put in something that's going to fail. Now it says, hey, this result failed. Do you want to measure it again? Maybe I, had a typo or something. I look over at this, but maybe not. Maybe it is actually a failed feature, right? So I'll say keep failed, and this can even prompt for NCRs. Okay, so I don't want to get too deep into this. Well, yeah, let's show the workflow. But this is showing me any active NCRs that are already opened against this job. Okay, so I might have the same problem recurring multiple times across multiple pieces. And so I can attach this new problem or this new failed result to an existing NCR, or I can make a new NCR. Okay, so I'll click add new. And so it walks me through a workflow to say, here, what was the machine that cut this particular piece? What was the inspection center where you were inspecting it, right? Any comments, any statusing that we want to apply here. There's a whole lot of details to get into, but I'll say okay. And then we get into kind of the beginnings of root cause analysis where we can say, give me a defect code for this. Okay, so I've got a few different codes in here. There's a legend here for saying, okay, what are some different, what are the actual definitions of these defect codes, right? In case you forget, that's good for early on. Over time, people just understand and remember what they are because they do this all day, every day. But I'll just select a particular code and say what the cause was of the failure. Okay, and then I'll hit OK and close, and that enters that NCR against that particular feature, and then I can move on with my next inspection. Okay. So something important is a lot of times when we show this to companies, the initial thought is, oh, I already have a system that manages my NCRs. Great. You probably don't get the a touch point directly on the shop floor to be able to trigger an NCR creation. And so we can provide that value to where the inspectors can generate the NCR at the point at which a failure occurs on a part, and then use our API and sync that data to whatever other system that you want to manage your NCRs through, if that's the case. So it's extremely flexible. This is an enterprise system that, well, it'll support from the small to medium businesses up through an enterprise grade organization. And that's important to realize there. All right, so now if I refresh again, you'll see that there's now a failed feature on that particular sample. So everything's being synchronized in real time here. All right, so something else, let's pull back a little bit here and review. So if we look at that particular operation we were on, I think we were on mill finish. Yes, here we go. So here were the two results that we just input, right? And so I can see that failure here. I can see who it was measured by, and I don't think I reported a gauge when I reported that, when I did it just now, but that gauge would show up there as well. Here, let's find another one where we did report the gauge so you can see it. These ones. Yeah, so when we reported the threads for this one here, what we had was the M8 thread gauge, the 256. So that shows up here with the result. Now, all of this is reportable. Okay, all this can be reported on through lot inspection reports, through your first article reports, etc. All that's there. It's not just in the database. You can export it into other forms. Over time, what we found is our customers tend to start off with generating lots of reports because that's what they're used to. But over time, that goes down because people learn to work with the system and just look for the information that they need, and they can find it here. So you don't have to deal with external static reports that aren't dynamic. And updating over time as production occurs. Okay, cool. So I talked about gauges. Let's kind of double down on this. Remember, this is a 256 gauge ID here. So let's go over to our measurement gauges that we have. So we have a complete measurement gauge library where you can manage all of your inventory, your calibration statuses, etc. So we know when a gauge is in or out of calibration or when it's about to expire. Okay, we can even send alerts and notifications based on that. 2 different emails here that you'll see, email types that you can send to however many email addresses you'd like to, but one for if any gauges that are already expired, and then another one for gauges that are about to expire in the next 30 days. Okay, so you can set these on whatever schedule you'd like. If it's, say it's a week, say it's once a month, etc. So you can stay on top of all of your calibrations. Now, I didn't show this specifically on the shop floor, but if there's a gauge that is out of calibration, it won't show up on the shop floor. If it's about to expire, it shows in red saying that the calibration is coming up soon. You might want to think about whether or not you're going to use that particular gauge. Okay, but if we look up that gauge that we had, remember we had this M8 thread plug gauge here, the 256. What I want to show you, this is one of the biggest values that we bring to the table with regard to gauge management, is automatic usage history. So you'll see this tab here. Remember those 2 results that we input for that part. That was the part number, the job, the lot, the serial number 11, and 2 different dimensions that we input results against. So they were just pass fail, so there's no numeric data there, but it's tracking each instance or each time where the gauge was used to record a result. Okay, so you'll have a complete history here. So that way, if you have some sort of a problem, let's say you send this gauge out for calibration, it comes back, you find out there's an issue, you can look back over a period of time, because we've got timestamps here, the users, etc. So you can look back over a particular period of time, 30, 60, 90 days, and see every time when that gauge was used and go and reinspect those parts if you need to ensure that you were getting good results that are reliable. Okay. So again, centralized database gives you all this sort of power and flexibility to be able to do this sort of activity here. Okay, so last thing that I want to get into real briefly is, let's kind of reset my screens here. Let's come back into the finished part like so. Yeah, we'll clear this guy. All right. Last thing I want to get into here is let's talk about SPC and what that looks like on the shop floor and in the back office. So I'm going to do 2 things. I'm going to open up a part here that I had that's got some SPC already loaded in, because I wanted to have a series of samples that's fully inspected. You'll see there's no more yellow here. And so that'll let us pull up our SPC graphs here. So the way this works, because we're collecting all of this data, it's only logical that you would want to be able to see it plotted out in different ways to be able to analyze it, right? And report on it in detail. And so you'll see if I scroll over here a little bit, you'll see these checkboxes for collect SPC. And so I can flag which dimensions are critical to me or the most important that I want to monitor SPC trends for. Okay, in this particular instance, we have a lot because I wanted to show you a whole bunch of dimensions being tracked all at once. So that's part of our plan. But I can go over now to this SPC tab I have up here, right? Very simple. And this is all being generated and updated in real time as results are collected from your CMMs, from your shop floor applications that we just talked about. All of this data is fed and revised in real time. Okay, and so each one of these charts here that I'm seeing is representative of a single dimension. Okay, for this part, I can add filters over here to look at specific operations if I want to, specific time ranges, even on specific machines and for particular gauges and so on. I can filter by a whole variety of different means here, right? And I can open any of these up and see more information. I can see all of my deviation, all of my statistical information, whether I'm stable, capable, and all my raw data is in the background there as kind of like an audit trail, so to speak. So let's say, I'm going through one of these charts and I'm looking and I see, okay, well, those were my extremes here that I had. And so I can click it and you'll notice, so that's sample number 18. It brings me to that sample number, okay, or it's sequence number 18, I should say. And I can review what went on there, I can see who, in this case, I don't have all the data populated because it's just simulated data, but you would have the gauge that was used to inspect that particular feature. You'd have the operator, which operation it was in. And if you're doing injection molding, you have things like the fixture and the cavity that sample came from, right? So all of that information is tied automatically into that centralized database and then plotted for visual trend analysis, okay? Histograms as well. All right, so that's on the back office side of being able to see the SPC trends, but what about on the shop floor where we want to see things in real time to be able to adjust our processes before something happens? We can be preventative with our quality inspections, not just reactive, right? And so if I'm seeing a particular trend away from nominal in a consistent direction, then I want to correct my process, adjust my offset, see what else is going on the CNC machine, something like that. So let's switch back over here. I'm going to go to the other app that we had for SPC. Okay, I'll log in for this one. And I'm going to go select my part, SPC example here. I'm selecting that particular job, and I'm going to pick which dimensions that I want to review here. And so a way we make that real simple, I can say, well, just tell me which ones require SPC monitoring, similar to those checkboxes we showed on the system previously. So I can filter by that if I'd like to. In this case, I'm just going to pick a few of these dimensions to monitor, like so. All right, and I'm going to say select those, and I can see now a dashboard that's showing me the SPC trends just for those features I selected. Okay, so the operator kind of gets to choose, has some flexibility about what he thinks is the most critical, or this could also be to a degree dictated from the quality planning side by telling the operators, hey, these are the dimensions that we feel you should be monitoring most closely, right? So the operator gets to build the dashboard though, and see when there's trends. Now, as they're going through production and they need to add inspection results, they can just click a particular dimension, say you want to measure it, and they can add their inspection results to additional samples, okay? So I can just input my result here. I've got my trend of the previous few results that have come through. I've got my target CPK, PPK values, my actual CPK, PPK values, right? Whether the process is stable and capable, okay? What my gauge is that I should be using. In this case, it's a CMM. We'll kind of pretend that's something a bit more manual. And I can just input my result that I get against the value here. So I'll just put something in, hit OK. And you'll see that one came through just on nominal, that this graph is updating as I go here. And so I'll do something a little higher. So 498. So that's a little above now. We'll do 499, keep going up, and 0.50, keep going up like so, and then 0.496 again, back down to nominal. So you can see kind of how everything's updating as we move along here. So I can input my results for my pieces, and then I go back to my SPC dashboard here, and I can pick another dimension if I'd like to. Okay, so all of these tools, just to summarize, having them in one single ecosystem like this is extremely powerful. Being able to kind of reduce down all of the analytics and all of the reporting so that you're doing minimal additional clicks or additional data entry, right? From a planning perspective, and everything's seamless and in one place. So with that, we'll wrap the session, and I believe we have a Q&A section at the end of this.
Yes, we do. I think we have Jack with us as well, right, Jack?
Yes, there are a number of questions
Yeah,
that have been asked.
I see them so I can walk them through?
Yeah, all you have to do is at the bottom of your screen, there's a Q&A.
Yeah,
with
I
a
see,
number.
I see the questions.
Okay.
I open it and I saw the last comment. Wow, massively integrated system from Joe Clements. Do SPC rule violation raise a flag or warning in real time? Well, I think that's exactly what Chris showed. But I think we can also initiate alert that can go, to relevant people, not just when we have a tool that is out of calibration or going to be out of calibration. We can alert relevant people when issue raised while data is collected on the shop floor. Is that right, Chris?
Yeah, for a variety of things right now, we can raise alerts based on events that happen on the shop floor. There's definitely many more that we want to apply in the next, that's something that we're going to be focusing on in the next few months, as well as expanding the types of events that we alert based on. But yeah, there's, depending on what you're looking for, there's a variety of things currently in the system that we alert on.
Going up in the ladder, regarding gauge calibration, is the system capable to uploading calibration certs, as well as we have an easy way to view the certs? I think the answer is yes. Let's go ahead, Chris. You can show it actually.
Yeah, 100%. That's actually a really good question. It's a major aspect of quality. So you'll notice here down in the bottom, see, I actually tagged the material as material objects. So we've got a little tool over here for flagging materials. So if I go up to my materials and processes here, you'll see I've got that material item in my system. Okay. So I can set additional details here. I might want to pick who the supplier is for the material and so on. And this is, excuse me, this is all job specific. I'm inside of a particular job now. So you might have a library that's general materials, but then for each job you say, excuse me, just a second. So for each job, you would say what the cert number and the supplier and approval and all that are for the material. And you can also upload material certs. That's kind of the general question that you asked. So you would upload those.
And you can also calibration certs, which you have in the tool engage management, I think, right?
Yes. Okay. Yep. I see that now. Yeah, he was asking gauge certs specifically.
Yeah, correct.
Yeah, so for measurement gauges here, you can have the cert number and the cert expiration loaded here, and you can also upload attachments against those. Okay.
Mm-hmm.
Okay, good questions.
Yep. From David.
Yep.
I think it's a question, what happened when you run the same operation on multiple inspection centers, like work center example? We could rough a piece on a multiple work centers. Okay.
Yeah, good question, David. So similar to how you deal with how we deal with gauges. So I think we talked about this where you would plan at a category, plan for a gauge category like thread plug gauge, right? But then it's the operator on the shop floor who's going to specifically say, okay, this was the inspection center or the machine that I actually created the sample on. So in addition to reporting on a result and the gauge that you use, you could say the machine and so on, right? So that's the general idea there. So when you have an operation that could run on multiple pieces of equipment, you would just plan at like what we call a work cell, which could be a group of machines with similar capacities or capabilities. So.
Okay. Does it provide capability to do gauge R&R or other MSA studies so I can address it? It's coming. It's not there. It's not there yet. It's in our roadmap for the very near future, somewhere early mid 2021. Just to give you an idea, I mean, our development plan is very robust, heavy, and busy. And for us was the most important thing to have a tool and gauge management really integrated with quality management system. So that was our first priority because it's provide the most value. Now, we have customers who are using our system and still having other system, which is perfectly okay. And we have the capability to import data or gauge on a daily basis, on an hourly basis. So you can continue to use your previous system communicated with our system, but Gauge R&R and other studies are in the very near horizon.
Yep.
Um,
There's another one by
Go
Jordan
ahead.
that I thought was a very good question.
Go ahead.
How can Jordan asked, how can I give an operator an instruction on how to measure something? That's a great
good.
question.
Mhm.
So you can build an entire instruction library in our system. We have the kind of tools for that on the inspection manager side, and then assign or map the various instructions to specific operations and even specific dimensions. Okay, so if you've got a procedure or an instruction set that tells you how to walk through an entire operation, do that. If you've got ones that are specific to very specific dimensions, you can do that as well. But basically, through the shop floor applications that we have here, I was just showing you how you deal with inspection, but you'll notice there's a tab down here, right, for instruction that I can click. And now I don't have an instruction loaded on this particular one, but you'll notice this blank screen. This is a PDF viewer that it'll just pull the mapped instruction down for the operator so they can scroll and zoom through this and view the instruction in the exact same interface where they're inputting their inspection results. So it's all right there at your fingertips.
Okay. Is there any limit of, this is NKit, is there any limit of dimension? Like can cover only 100 dimension like that? I don't think.
Let me put this in perspective. So we have a customer that I won't mention because it's a webinar, but we have a customer that builds very, very large parts and assemblies, vehicle systems, and they have drawings that are upwards of 500 to 800 pages and upwards of 8 to 12,000 dimensions on a single part. So yeah, no, we don't have limits.
Lowell, this is how this software applied, cloud-based, purchased by seats, sold to customers for installation on network. Can you purchase module? Kind of all of the above. It's cloud-based, or it's not cloud-based in a way that you look into it, but for instance, the shop floor data collection is browser-based. So you use any tablet or PCs or whatever operating system that has a browser. So this is for the shop floor data collection. We are client-based, so many of our customers are defense and aerospace, so they don't like very much cloud-based unless they hosted themselves in their intranet area. So it's a client server. It comes with a centralized database. It starts with the base package, what we call job shop. I can throw a number just to give you an idea. It's about $5,000, including license, training, and 12 months support, maintenance, and software upgrades. And it can go up based on module, number of licenses, etc. But that's the way you can be. You can start as small as you feel like, and you can scale up by modules and number of licenses as you go.
Well, they're good questions. I was picking up, Sam. Sorry, were you done?
No. Maybe yes, but I scroll down. But if you see a question that you need an answer, please do.
Yep. So Jeff asked, what kind of computer hardware and gauge interface equipment is needed to at each machine to collect the measurements? And I'm going to couple that one with another question that was asked by Yan Li. They said, does your system support iOS and Android devices that inspectors can carry on the floor? So with regard to hardware on the shop floor, yes, you can. It's browser based, so you can use it on iOS or Android or Windows systems, PC or tablet, because it's browser based. We're currently certified for, we've certified Chrome, but it works very well in other browsers. We just haven't gone through the full rigorous QA testing for other browsers just yet. That's still in process, but absolutely Chrome works really well on all those systems. And then as far as gauges, specifically like digital gauging equipment, we'll interface with just about any digital gauges that are out there. But if you're looking for recommendations, we have done a lot of testing with Mitutoyo gauges, and we know that those specifically we can couple with their receiver identities to be able to do what I talked about, where you can have the gauge automatically transmit the ID, the gauge ID into this field here. Not all gauges do that, but we do know that Mitutoyo ones do that very well. And they're a very, very popular brand for digital gauging.
Okay. I think I see. How do you handle results from multiple places? Did we address this question, Chris?
I haven't answered it, but I'm not totally sure.
That's what I'm trying to
they mean
understand.
by
Where
that.
where is this question?
Yeah, results from multiple places, maybe like different facilities or different inspection areas. I guess the short answer would be, aside from not knowing specifically what you're getting at, Thomas, I don't think it matters much. We'll take results from anywhere, and we have plenty of tools to provide traceability information for who inspected it, where, when, maybe even why, why they
Well,
inspected it.
Well, we can say the following, if this is the question. Actually, we have many customers, and you saw on the list. I mean, I can share with you that Lockheed Martin, they installed a database in a central location, and then there are multiple locations working with our software.
Yeah, he
And
just
it all
qualified.
He just qualified it. Yep.
Oh,
Yeah.
that's the.
Yeah,
this
he
was
just qualified the
question.
question. So let me show what
Go
that
ahead.
is.
Okay.
So yeah, so when you say multiple places, Thomas, he's asking for like a 4x multiplier.
I got it.
So you'll see here, the way I have this set up, we can do this in a couple different ways, but the way I set this one up, there's 4x on the diameter thread shoe position here for this one. And so you'll see I have multiple instances of each of these. So there's actually 12 line items here that I have, and there's diameter thread shoe position, diameter thread shoe position. So it's 17 is the balloon number, 0.123 for the diameter thread shoe position, _1. Okay, so that's the first instance of each of those items. And then there's an _2, _3, _4. And we can even do this in a different way as well. You could, bring this back up so it's summarized. So now I've just got 17.1, 2, and 3, and now there's a 4x multiplier on it. Either way that you want to represent it here is perfectly fine. We can even do this.
Yeah.
I'll show you.
Yeah, in the setting, you have to do the balloon.
Yeah,
Right.
Yeah, let me just turn that on though.
Yeah, correct.
So, yeah, I'll leave
Yeah,
that on
that's one.
So, yeah, we'll sync those back up. So the way this works here, right, is let's go here.
Multiply.
So I can actually multiply out the dimensions themselves. Okay, so I have multiple balloons to actually mark where each instance is on the drawing. Okay, so now it's not just arbitrary. Now when I get a result for 17_1, it's for that specific hole. And you can do this for literally hundreds of instances. Like if you have some sort of like rivet along a long manifold, you could have literally hundreds of multipliers and maps them and drag them where they need to be. We even have a multiplier manager tool that lets you, some drawings we've seen have multiple instances across different sheets, like drawing sheets in the same drawing. So if you had multiple drawing sheets, we can even locate them on multiple pages as well. So
just on the practical life, to address this question, I mean, you can have here, instead of 4 holes with 3 calls out, you can have 50 holes at 3 calls out, and you don't want to see in your bill of characteristic 150 lines. But even if you don't apply the multipliers, those requirements are in the database. So when you generate inspection plan or when you get inspection results, the system accept or expect actually to get those results. If we are not getting it, then we tell you. I don't know if you had a seconds to simulate reading inspection results, but the system gets inspection results, of course, from any tool, as Chris mentioned, and it goes directly to the database, including color coding the print based on the results: red failed, green pass, gray not inspected, etc. So we're getting to the top of the hour. I think there is another question by Gary. Can the sequence of data entry be locked, i.e. sample to can't be? Yeah, go ahead.
yeah, I think Gary's asking specifically about like operation sequences and
Correct.
making sure that people inspect in the appropriate order. So it's not something that we're doing today. We've had multiple companies that have asked about it, but every time we dig into it to do like an analysis, there's always some reason why they don't actually want it. So if there is a company that really wants it and there is a clear line of logic and workflow where there's not going to be a bunch of exceptions that come up by putting that logic in place, we're happy to look at speccing that out and building it. But so far, we haven't found a company that really wants to commit to that. So,
Okay,
And
Chris, I think there's one last question
I
that
would like
you
to
can answer
address it.
quickly.
There are two, but I would like to do it quickly. How easy would it be to share file with others who may not have the SIT, specifically distribution? So we don't, there's going to be another webinar on supply chain coming soon, which Jack will talk about it. Probably, I think we have in December something. But today we have customers who work with other suppliers and actually generate inspection plan and 2D print in one click. Can you create inspection plan one click on this, Chris?
oh, just balloon a print?
Balloon, no, you have the balloon, but inspection plan. Go to inspection.
Oh, I see.
That's
yeah.
it. I'm just give you the idea how many of our customers are doing today, and you're going to see it. And actually, they give their supplier, you see the inspection plan here, all the requirement here. Now, we created now a standard language between us and our supplier because we took interpretation from them. The requirements are here, and all they need is to put actual here. Once you have actual here, you can import it back to our system and you get inspection results like they become your extended shop floor. So I'm giving you kind of a high level, but yes, it's capable, available, and we have customers who are doing it. We have supply chain, which is more collaboration, and it's more, very well, I would say, managed with supply chain, with collaboration and workflow and other things.
Yeah, and I didn't show this in the presentation, but as far as first articles as well, and being able to populate the results automatically into a first article. This is the AS 9102 Form 3. This is standard. It comes default with our system. So if you do something with this form, or if you have other formats for reports, then we have an entire report designer to be able to build custom formats that meet your needs specifically. So,
all right, will be kind of the last question. How does your system communicate with other software, for example? Okay. So we have an API, and actually the question is, Polyworks is more on the 3D side, and we can provide them the bill of characteristic with one click. And I believe that Polyworks as an API. Go ahead.
No, isn't Polyworks the CMM programming software?
Yeah, they're doing 3D, right? Yes, they're getting 3D and they're running CMM on any CMM machine. And I don't know what system they are using, the Globus, 3D. But if we are talking about providing them or any, and now we work with VeriSurf, not just Polyworks and many others. So there is an API, application programming interface, and this is the tool that we integrate with any outside system. And all those companies like Polyworks, VeriSurf, and many others having their API, which is an open API, and we integrate outside of the software. So you don't want to do every version that Polyworks will release or we will release. We have to build new integration. So it's done outside of the software via API on both sides, and that's easy to do.
And just in case you were asking about pulling data in from Polyworks, like results data, we have a ton of customers that are using Polyworks and generating results data. So
we need to maybe address bonus tolerance for applicable GD&T. This is a question that needs to be addressed and educate probably about bonus tolerance for GD&T.
Yeah, we can follow up if there's specific training needed on that one for that.
Yeah,
customer.
But we can
but-
discuss about it. Yeah.
Yeah, it's definitely something that we do, though. If as far as GD&T and bonus tolerances go, we can take that data from the CMM directly for the output on the GD&T, and it's able to be reported on. And the pass-fail analysis is based on that bonus tolerance availability, and all that's handled quite well and elegantly.
All right. I think we went a
Okay.
little bit above
Yep,
the
we're a
time,
few
but
minutes over,
that's okay. So take
Yep.
it from me. Thank you, everybody. Go ahead.
right?
Jim.
And let me just take the control here and share my screen. So I want to thank you for showing up today and for spending the time. We did go about 5 minutes over, but I think the information was very worthwhile. We have a couple of upcoming webinars next week. Tuesday, we have a webinar combining ProShop ERP and Inspection Manager will boost your quality efficiency. And then on Thursday, adopting 3D models with PMI expands your quality process. Both of these links will show up in your recording, which will be sent tomorrow. Link will be sent to that tomorrow. And you can also register for both of these webinars. Just go to our website, highqa.com/news, and scroll down to the bottom section. You'll have links to both of these webinars. Encourage you to sign up and register if you are interested. Even if you cannot attend, we will send you a link after the fact with the recording. And as Sam alluded to, in December, I believe it's December 9th, we have a session on HighQA 360, our supply chain product. That is being delivered live to Europe. So it may not be an appropriate time for everyone, but if you register for that, we will make sure that you get the recording link as well.
Yeah, it's actually worldwide presentation on the supply chain. So yeah.
All right.
Okay.
And then one last thing here, of course, thank you for attending. For more information, there are a couple of ways you can contact us. You can call us 888-727-1266, send an email to info@highqa.com, or visit our website where you can get more information about the company, our products, and also complete one of our contact forms or requesting a demo form. Thank you for attending and look forward to having you with us again next week.
Thank you, everyone.
Thank you, everybody.
Bye-bye.